Supreetha. Welcome to my math class. So in the previous lectures on hypergeometric series, we studied about the introduction on hypergeometric series. Yes, that is the pachamar symbol. We studied about the convergence on hypergeometric series. Yes, what else did we study? We studied about hypergeometric equation, the proof. Yes, and then in the last video, we studied about binomial theorem. Yes, the proof of the binomial theorem. So what are we going to study in this video is integral representation. Okay. So what is a statement for integral representation? Okay. Integral representation. Yes. So yes, the statement is for real of c greater than b, which is greater than 0, we have, yes, 2f1. What is this 2? 2 represents number of terms in the numerator. Yes, this z is variable. Okay, and then this is equal to gamma of c divided by gamma of b into gamma of c minus b. Okay, integral, yes, integral 0 to 1. Okay, t power b minus 1, 1 minus t to the power c minus b minus 1 into 1 minus zt to the power minus a into dt. Yes, let me start the proof. So what is beta integral? What is the formula for beta integral? Yes, the formula for beta integral is integral 0 to 1 t power x minus 1 into 1 minus t to the power y minus 1. Okay, y minus 1 dt is equal to gamma x gamma y divided by gamma x plus y. Okay, so now, yes, on seeing this term, you should already guess that binomial theorem pitches in, right? So let me write the binomial theorem statements. What did binomial theorem state? Yes, so for mod z less than 1, what do you mean by mod z less than 1? That the series converges. Okay, so for mod z less than 1, we had summation n is equal to 0 to infinity an divided by n factorial into z power n is equal to, what was it? 1 minus z to the power minus a. Right? So now to get this term, let me replace z with zt. Okay, let me write that down. Replacing z by zt. Okay, so I would get n is equal to 0 to infinity an divided by n factorial zt power n is equal to 1 minus zt to the power minus a. Okay, let me substitute this in this equation. Okay, that would be integral 0 to 1 t power x minus 1 into 1 minus, okay, where do we have 1 minus zt to the power minus a? That is in this equation, right? So yes, let me substitute that in this. Yes. Now consider integral 0 to 1 t power b minus 1, 1 minus t, c minus b minus 1 into 1 minus zt to the power minus a into dt. Yes, so in this place of 1 minus zt, let me substitute that value. Okay. So yes, what would I get? Integral 0 to 1 t power b minus 1 into 1 minus t to the power c minus b minus 1 into, let me write dt. So I would get here summation n is equal to 0 to infinity an divided by n factorial into zt to the power n. Okay, so I would have to take the dt over here itself. Yes, so now let me take the summation first. Okay, let me write it as summation n is equal to 0 to infinity an divided by n factorial z power n. Okay, and then the t terms, that is 0 to 1 t power b minus 1 into 1 minus t to the power c minus b minus 1. So I have n over here. Yes, let me just add it directly. Okay, so you would get dt. Yes, now what was the formula for beta integral? Let me write that down. So the formula for beta integral was 0 to 1, yes, gamma x, gamma y divided by gamma x plus y is equal to 0 to 1 t power x minus 1, 1 minus t power y minus x minus 1 into dt. So do we have 1 minus t to the power y minus x minus 1? Yes. And do we have here x to the power? Yes, if I can write it as b plus n minus 1. Yes. So how can I write it in this formula? Yes, so I can write it as summation n is equal to 0 to infinity an divided by n factorial z power n. So in the place of x, I have b plus n. Yes. And in the place of y, I have c minus b. Okay. And in the place of x plus y, I can write c, okay, b plus n plus c minus b. So b and b gets cancelled. So I would have to write it as, okay. So what was beta integral formula? Yes, so we had integral on only one side, right? So I should have to erase this. Okay. So yes, this is equal to summation n is equal to 0 to infinity an divided by n factorial z power n gamma. So I can write gamma b plus n as, yes, I can write gamma b plus n as gamma b into bn. Okay. So c minus b would remain as it is. So over here I would get b and b gets cancelled, right? I would get gamma c plus n. So I can write that as gamma c into c at n. Okay. So what else? Let me take out gamma terms. Yes. Gamma c minus b divided by gamma c. Yes, so I have here summation n is equal to 0 to infinity an bn divided by cn n factorial into z to the power n. So what is this? Isn't this the formula of hypergeometric series? Yes. So I would get gamma b, gamma c minus b divided by gamma c. Yes, and 2f1 of a, b, c, z. Okay. So what did we have on our LHS part? We had the integral, right? What was that integral? That was integral 0 to 1 t to the power b minus 1, 1 minus t to the power c minus b minus 1. Yes, and then 1 minus zt to the power minus a dt. So if I send this term to the LHS, yes, I would get the statement of integral representation. Yes. So how did we prove this? We took the beta integral. Yes, we wrote the formula for beta integral first. And then since we have 1 minus zt to the power minus a over here, we took the statement of binomial theorem. Yes, we wrote down the statement. We replaced z with zt and we arrived at this equation. And then we took only the integration part on the RHS and we proved that that is equal to the other remaining terms. Yes. So that is it for today. Thank you.